This is Dr. D. Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today the topic is Kinetics, Introduction, Important Terms, Newton's Laws of Motions, Relation between the force and mass. The definition of mechanics is it is a branch of science which deals with the behavior of the body when the body is at rest or in motion under the action of forces. Engineering mechanics. It is a branch of applied science which deals with the laws and principles of engineering mechanics and applications toward the engineering. Hence, this engineering mechanics subject is most important to the profession who are interested to settle as designing and construction and planning and the various types of structures as well as the machines. The subject of engineering mechanics is broadly classified into two types: statics and dynamics. The dynamics again further divided into kinematics and kinetics. First I am taking the statics. Statics is the branch of engineering mechanics which deals with the forces which are acting on the body when the body is at rest. The dynamics. It is a branch of engineering mechanics which deals with the forces and their effects while they are acting upon the body when it is in motion. The subject of the dynamics is further classified into kinetics and kinematics. Kinetics again it is a branch of dynamics which is a part of engineering mechanics which deals with the body's motions as well as the forces which are influence the motion of the body. Kinematics. It is a branch of dynamics which deals with the motion of the body without considering the forces which are involving or influence the motion of the body. Newton's first law. It said that everybody continues in a state of rest or in uniform motion in a straight lines unless it is compelled by external agency acting on it. Example, the body in motions would remain in motions unless the force, it may be the frictions caused to come to the rest. The frictions, it may be the lateral brakes also. Newton's second law. It says that the rate of change of momentum of a body is directly proportional to the impulsive force and takes place in the direction of the force acting on it. According to this law, the force is equal to rate of change of momentum, which is equal to m into v minus u by t, or v minus u by t, that is called rate of change of velocity. It can be written as a, that is f is equal to m into a, or in other words, it will be the definition of the force. Newton's third law, it states that for every action there is an equal and opposite reactions. Okay, some of the terms which are generally used in engineering mechanics, particularly in kinematics, are: one is the speed. The speed of the body may be defined as the rate of change of distance with respect to its surrounding. The speed of the body is irrespective of its directions, hence it is a scalar quantities. Here, rate of change of distance means particularly we are not at all mentioning any directions, Hence, the speed is treated as a vector quantity. It is having only the magnitude but not the directions. Velocity. The lowest the body may be defined as the rate of change of displacement with respect to its surroundings in a particular directions. Hence, it is called vector quantity. That means it can be represented both in magnitude and directions because we are saying it is in a particular directions. Accelerations. The acceleration of body is defined as the rate of change of velocity. That means here it can be written as now A is equal to V minus U by T now. That is rate of change of velocity. That means change in velocity divided by the time. It is called acceleration. If the value is a positive, that means if the velocity of the body is increasing, then it is called accelerations. But sometimes because of application of forces, friction forces, or it may be the brake forces, the body is decreasing its final velocity, then that acceleration is in negative, then it is called retardations. Uniform accelerations. If the body moves in such a way that its velocity changes in equal magnitudes in equal intervals of time, then the body is said to be moving with uniform acceleration. Variable accelerations. If the body moves in such a way that its velocity changes unequal magnitudes in equal intervals of time, then it is said to be moving with variable accelerations. The distance traveled. If the body is moving with uniform velocity v in a given time t, the distance covered is given by the velocity multiplied by the time now. That is the distance traveled is equal to the product of velocity and the time now. Equation of motion in a straight line under uniform accelerations. Already I told the uniform acceleration means the velocity of the body changes in such a way that equal in magnitude in a equal intervals of time, then it is called uniform acceleration. Now we are considering the equation of motion in a straight line under uniform accelerations. Consider motion of the body moving from point O and moving with the OX, that is in horizontal directions, as shown in figure now. Let U is representing its initial velocity and V is representing the final velocity after interval of time t, that is according to the figure it reaches a point P. A is uniform accelerations and S is the distance travelled in t seconds. So equation of motions, equation for the final velocity. Here the acceleration is the rate of change of velocity, it is given. Now we discuss now small v is representing final velocity and u is representing initial velocity. The change in velocity is equal to final velocity. It is the difference of final velocity and initial velocity, v minus u. The rate of change of velocity is equal to change of velocity divided by time, hence it is equal to v minus u by t now. But the definition of acceleration is it is the rate of change of velocity, hence it is also called a, that is a is equal to v minus u by t now. Or from these equations we got a t is equal to v minus u, or the final velocity is equal to v plus u plus at. This is represented in equation number 1. So by using these equations we can determine the relationship between the initial velocity and final velocity by using the terms accelerations as well as the time taken now. So in kinematics, we are not at all considering the what are the forces that are influence the motion of the body. Only we are considering the terms, that is what is initial velocity, final velocity, acceleration, the distance traveled as well as the time taken now. The second equation is equation of motion for distance covered. Here we have to determine the distance covered by the particle when it is having initial velocity u, final velocity v, and moving with the uniform acceleration a. After time t seconds, the distance covered we have to determine. Since the initial velocity and the final velocity is given, the average velocity is given by the average of final velocity and initial velocity, which is equal to v plus u by t now. So the distance covered is equal to the velocity and time now. Here the velocity is the average velocity, which is equal to v plus u by t 2 and multiplied by t. This gives the distance covered by the body. And cross multiplication we got now. S is equal to this v plus u by t into t. In this equations we got t is equal to, by using the equations here, v is equal to u plus at is there now. It is nothing but equation number already represented now. T equal to, we can write as just v minus u by a now. Substituting this values the equation this one now. We got u plus at, it is there now. Again plus u by 2 into 2 now. This is nothing but equal to v is equal to u plus at we have taken, and u already there now by 2 into t, and multiplication we got to 2u plus at by 2 into t. So from this equation we got to ut plus 1 by 2 at square, which is equal to s, that is the distance covered by the particles when it is moving with uniform acceleration c now. The third equation, so the relationship between the velocity, initial velocity, final velocity, acceleration and distance covered. So by using the equations, that is v is equal to u plus at, we can determine t is equal to v minus u by a now. So according to the previous equations, we got s is equal to ut plus 1 by 2 at square, which is used to determine the distance covered by the particles in terms of initial velocity, time taken and accelerations. So here I am removing the two t terms and placing that values v minus u by a in this equation. That is u, t is equal to v minus u by a plus 1 by 2 a, t square is equal to v minus u by a whole square now. Okay, on simplifications we got to v square minus v square is equal to 2as. That means this relation is giving the distance covered by the particles in terms of velocity, initial velocity, final velocity and as well as the accelerations. This acceleration is the positive if the change of velocity is gradually, if it is increasing. If the final velocity decreases, that acceleration is called here retardation. Negative value we have to substitute in that above equations. The velocity and acceleration of the body moving in a straight line by differentiation. So velocity is equal to, we can take it as distance travelled by the time taken. When we are taking infinitely small distance, that at that instant the velocity is given by ds divided by dt, where ds is representing the distance covered in time dt now. So acceleration is equal to dv by dt, that is change in velocity by time, but at any instant it will give the dv by dt, which is equal to d by dt into, here velocity is equal to, we are substituting ds by dt, From this equations we got to dts by dt square. These are nothing but generally useful for us for solving the certain problems when s is given in terms of time now. So by using this equation, we can determine the velocity as well as the accelerations at that given instant now. Distance traveled in a nth second. Let u is representing the initial velocity of the body and a is representing the acceleration of the body which is moving with the uniform acceleration. Let Sn is representing the distance covered by the body in n seconds. And n minus 1, yes, n minus 1 is representing the distance covered in n minus 1 seconds. So according to the problem, just we require the distance covered in only nth second now, which is equal to the distance covered in n seconds minus the distance covered in n minus 1 seconds. So Sn minus Sn minus 1 and substitute the values we got to u plus a 2n minus 1 by 2. This is the general equation required to determine the distance covered in nth second. Okay, velocity and displacement of body when it is moving in straight lines by using integration now. The velocity, it is given already ds by dt. So from this relation, so ds is equal to, on cross multiplication we got to v into dt. So s is equal to, it obtained the integration of v dt with respect to the t plus some constant we got to, that c1. Similarly, acceleration is equal to dy by dt, dv is equal to a into dt and cross multiplications, or v is equal to that integration of a dt plus c2. So this c1, c2 are called here integration constant that can be evaluated by using the conditions provided within the problem. So till now we covered the definitions when the body is moving along the straight lines on the surface of the earth now. But when the body is moving, this falling in downward directions, so the equation of the motions are changed. That means the acceleration is replaced by the g now. That is a is replaced by g. So the equations are now when the body is moving in downward directions now. So when moving in downward directions, the g values is taken as positive. So the relationship between the initial velocity and final velocity is given by v is equal to u plus gt. But when the body is moving in linear directions in horizontal, we are taken v is equal to u plus at. That means a is replaced by acceleration due to gravity, that is g now. Similarly, s is equal to here u2 plus 1 by 2 at square now. Here we are calling s is nothing but the distance traveled the surface of the earth now. But h is nothing but it is how much distance that traveled when it is falling in downward directions, which is h is equal to u2 plus 1 by 2 gt square now. The relationship between the initial velocity and final velocity is given by v square minus v square is equal to 2as, where s is stand for the distance traveled. But in the case of when the body is falling, it is termed as the distance traveled, that is the height traveled now. That is which is equal to v square minus v square is equal to 2gh, where h is nothing but representing from, that is the position of the body that is started from the ground level now. Similarly, when the body is moving in upward direction, so the acceleration is replaced with the minus g now. So in the above equation now becomes a is equal to minus d and v is equal to u minus gt, s is equal to ut minus 1 by 2 gt square, and v square minus u square is equal to minus of 2gh. Here when the body is moving in upward direction, so generally the g is taken as negative. When the body is falling in downward direction, so it is represented as positive g. The equations are similar to the motion of the body when it is in horizontal or moving in a straight lines. So some conditions are there now. If the body is start from the rest, means the initial velocity is treated as 0 now, that is u is equal to 0. When the body is coming to the rest, that means by applying the forces or by other means, then the final velocity is treated as 0 now. The body is projected vertically upwards means the final velocity of the body is taken as 0 now. At the maximum when it is reached now, the body starts moving vertically downward direction, so its initial velocity is treated as 0. The acceleration due to gravity is taken as positive when the body is moving vertically downwards, and negative when it is moving in upward directions. Okay, the relations between the initial velocity and the final velocity of the body when it is moving in circular motions. The circular motion means it is rotating in the form of circle having just a fixed radius now. That is the motion of the body in a plane along the circular path is known as curvilinear motions. In the circular motions, the center of rotation of always remains constant. That is, the body is moving at a distance of r from the center of the circle. The examples, the body is moving circular motions is one is the shaft. The shaft is rotating about its own axis, and the flywheels. Generally, in the machines, the flywheel is there now. Generally, in order to prevent just to minimize the fluctuations within the speed, the flywheels are used now. It is also rotating about its axis, and the pulley is also there now. These are comes under the rotating about own axis, that is in a circular path now. So angular velocity, it is defined as the change of angular displacement of the body. That is omega is equal to dt divided by dt. It is similar to the ds by dt earlier we have taken, where dt is representing angular displacement, omega is representing angular velocity of the body now. Angular accelerations, it is defined as the rate of change of angular velocity. It is measured in radians per second and per second or radians per second square now. Here the units of angular displacement is radians, time in t seconds, and so angular velocity is equal to radians per second. Similarly, angular acceleration is equal to rate of change of velocity, that means it is equal to the radians per second square now. Relationship between the linear acceleration and the angular acceleration. So we are having this, the velocity, linear velocity is equal to r into omega. When the body is moving along the circumference of the circle with an angular velocity omega, the linear velocity is given by v is equal to omega into r now. So on differentiating the above the equations with respect to the time t, that is dv by dt, it is equal to again dou by dt into omega into r. This is called here dv by dt is equal to, generally it is represented as acceleration, r into d omega by dt. This is equal to the relationship between the accelerations as well as the r in terms of rate of change of angular acceleration. But d omega by dt is equal to, that is the rate of change of angular velocity. It is generally represented as angular acceleration, that is alpha. Hence, a is equal to r into alpha now. This is the relationship between the accelerations and angular acceleration. The equation for angular displacement is given by, it is similar to when comparing with s is equal to ut plus 1 by 2 at square. This equation is applicable when the body is moving in a linear, where s stands for the distance covered in time t seconds, when it starts with initial velocity u and acceleration a. So when the body is moving in a circular path, the equations are s is nothing but the distance covered, here the angular displacement theta is equal to omega naught t plus 1 by 2 alpha t square now. Similarly, The relations between initial velocity and final velocity in terms of angular acceleration and displacement is given by omega square minus omega naught square is equal to 2 alpha into theta, where omega square representing final angular velocity, omega naught initial angular velocity, alpha is the angular acceleration, theta is the angular displacement. When the body is moving with the angular velocity of n, the angular velocity is generally represented by the equations 2 pi n by 60 now. Okay, some more important terms in kinetics now. Till now we discussed only the kinematics part now. Here in kinetics, it is already, we discussed it is a part of dynamics, in which the part of dynamics in which it deals with the motion of the body as well as the forces which are influencing it now. That is the here mass, forces, other the motion is involved now. The terms, important terms, matter. Anything which occupies the space, generally it is called matter now. Mass is a quantity of matter possessed by the body. Generally it is expressed in terms of kg in mks units. The weight, the force which the body is attracted toward the center of the earth now. Generally it is equal to m into g now, where m stands for the mass, g is equal to acceleration due to gravity. It is represented in terms of newtons now. Inertia, it is a property of the body possessed by which it resists the change of state of motion or the rest. Momentum, the quantity of motions possessed by the body, it is measured by the product of mass and velocity. That is mathematically the momentum is equal to m is equal to, it is the product of mass and the velocity. Okay, equation of motions here given. Let the relationship between here now, force as well as the acceleration in terms of m. Let m is representing mass of the body, a is representing uniform acceleration which the body is moving, t is equal to time required to change the velocity from initial velocity mu to final velocity v, f is equal to force applied now. According to earlier definition now, the rate of change of momentum, that is, it is equal to the force now. So, initial velocity is given by the product of mass as well as the initial velocity. Final velocity is equal to m into v now. The change in velocity is equal to mv minus mu. The rate of change of velocity is equal to mv minus mu divided by t. It is equal to m v minus v by t. Since a is representing the acceleration of the body, which is equal to rate of change of velocity, hence it can be written as m into a now. Or the rate of change of velocity is equal to m into a, right? But according to the problems, it is nothing but equal to the force now. That is, the force is proportional to the m into a, or f is equal to k into ma, where k is called here constant of proportionality. When m is equal to kg and a is equal to meter per second square when we are taking, then That is when 1 Newton force when it is applying and a mass of 1 kg to move with the uniform acceleration of A. When substituting F is equal to 1 also, that is we got K is equal to 1 now. Okay, some of the equation we are taking now. The unit of force chosen that it will produce a unit acceleration and a unit mass, that nothing but when F is equal to 1, M is equal to 1 and A is equal to 1, then K is also equal to 1 now. So when we are considering the friction force which is acting on a body, sometimes it is also called tractive resistance. The net acceleration is given by F minus R. This is called the total force that is acting, which is equal to M into A. From the definition, the weight is nothing but it is the force of gravity. That means with which it is attracted toward the center of the earth now. Hence, W is equal to, we can take it as M into G now. Sometimes the force is there now. When the body is moving in XY plane now, in order to find the resultant force when the system of forces are acting, generally the force is a result into two components. One is along the X direction, one more is along the Y direction now. The horizontal component of the resultant force is obtained by the algebraic sum of the horizontal component of all the forces, which is equal to sigma Fx is equal to M into Ax, that is X direction. Similarly, sigma Y is equal to, that is the component of resultant force in Y direction is given by M A Y now. Okay, these are the important terms which are related to the kinetics as well as the kinematics, which is a part of dynamics of engineering mechanics.
Like, share and subscribe. Hit the bell icon for more updates.